So you picked up one of these, and this is just a reference sheet. The ones we need today are on the notes. We're not learning all of this today. Well, actually, I guess all of this is part of what we're doing today, but the question came up, obviously, last period, like, are we going to have to memorize these? And the answer to that is no, because at this point, if I had you do that, that's exactly what it would be. It'd be memorization, because there are so many of them, they are so similar, and they are very easy to get confused. So the key here is that you can choose and use what you need and use it correctly. So on tests, quizzes, you'll have a card or something similar to the little half sheet of bright green paper that you have for you to be able to use, because you still have to be able to get through all the rest of the stuff. So that's going to go on page 115 whenever, whenever you put your stuff in there. But then this part is going to go on 116, and let's talk about how we're going to use this and what we're going to do. So these trig identities, they are basically ways to help you manipulate and simplify trig equations, because we're going to get it to the point where we're actually solving trig equations, and some of the basic algebra stuff that you've been using forever doesn't always work because trig's a little bit different. You have to cancel things out using reciprocals and whatnot. So all of these rules and this manipulation, we're still using algebra, and it's the same algebra you're using. You just don't have the same distributive properties, within the thetas and things like that. So let's look at these first. Well, first of all, this says a trigonometric identity is an equation involving trigonometric functions that is true for all values for which every expression in the equation is defined. So true for all values when it is defined. So what that means is, like when we have tangent of theta is sine over cosine, but that's when cosine of theta is not equal to 0. So this is like part of what's defined, because there may be things that you have to exclude or whatnot. So the identities help to evaluate functions, simplify expressions, verify identities, and solve equations. So we're just going to work through some of the very basic ones today. These basic ones right here, the quotient and reciprocal identities, you already know. Well, I didn't talk about them as identities, but we know them. You should know that the tangent of theta is sine over cosine, and you should know that cotangent is cosine over sine, and then these are just the reciprocals. So the key here right now is that it is possible on some of these to work them differently than what it's asking you to do. However, this is one of those cases where if it says to do it a certain way, you have to do it that way, because the whole point is that we learn how to work through this process so that you have that skill to use when you need it, right? Because anytime you learn something new, like we're going to make you do it that way so you learn the skill, and then eventually you get to decide how you're going to do it and what's going to happen, okay? But we have to work through it this way first. So it says here to use the quotient and reciprocal identities, which means there are other ways to work some of these, and we have done it before where we've drawn triangles and found stuff, but this specifically says to use these identities, basically so you can learn how to do it without having to do the triangle stuff. So number one is pretty simple. It says if secant of theta equals negative square root of 30 over 3, then I want to find cosine of theta. Well, how are secant and cosine related? Yeah, they're just the reciprocals. So secant is just the reciprocal of cosine, which means then that the cosine of theta is just equal to the reciprocal of this. And it is 1 over that, but you don't have to write it that way. I mean, you can, but you end up just taking the reciprocal anyway. So it's negative 3 over the square root of 30. And then, of course, you have to clean it up because we can't leave it like that. So that's going to give me negative 3 square root of 30 over 30, which means then that the cosine of theta is equal to what? Good, negative square root of 30 over 10. And we've already done problems exactly like that, right, when you've had to find them before. So that's nothing new. All right, so let's look at number 2. It says if the tangent of x is the square root of 2 over 4, and cosine of x is negative square root of 2 over 2 over negative square root of 2 negative 2 square root of 2 over 3, then find the sine of x. All right, so here's what we know. We know that the tangent of x is equal to the sine of x over cosine of x. That should be something that you already know. So basically, we're just substituting in. Tangent of x is square root of 2 over 4. That's equal to sine of x, which I don't know, sine of x, over cosine of x, which is negative 2 square root of 2 over 3. So before you go do anything weird with fractions or freak out that you have fractions and fractions, there are no reciprocals involved in this whatsoever. Okay, you just look at this as, what are we trying to get by itself? Sine of x, not even x, just the sine of x, right? It is being divided by this fraction. So to get rid of it, I multiply both sides by this fraction exactly like it looks. Does that make sense? So that means I'm going to get the sine of x is equal to negative 2 square root of 2 over 3 times the square root of 2 over 4. So what is the square root of 2 times the square root of 2? 2 times 2 is 4. So this all cancels out with that 4 right there. So I'm just left with the sine of x. Is it equal to negative 3? No, what is it? Negative 1/3. Don't do anything extra weird there at the end. Okay, easy enough? It looks real ugly, but it's not that bad. Questions? Okay, so let's look at number 3. I have the cosecant. I have the cotangent. I need the secant. All right, well, the only quotient identities I have are tangent and cotangent. And tangent is sine over cosine. Cotangent is cosine over sine. So I'm going to use cotangent here because I know that the cotangent of beta is equal to the cosine of beta over the sine of beta. But I don't have the cosine or the sine. I do have the cosecant. What is the cosecant the reciprocal of? Sine. So that means I know that the sine of beta is 3 over 7. Does that make sense? Because I've just taken the reciprocal. I know nobody asked me for the sine, but I know that much. Now I can use this. So the cotangent is negative 2 square root of 10 over 3. That's equal to the cosine of beta over the sine of beta, which is 3/7. Everybody with me? So now I multiply both sides by 3/7, and I'll get that the cosine of beta is equal to 3/7 times negative 2 square root of 10 over 3. I can't cancel anything out, right? So I get that the cosine of beta is equal to negative, wait, oh, you can cancel out the 3's. I'm sorry, thank you. I knew I was starting to write. You can cancel out the 3's. Thank you. Obvious that I don't know what I was doing. But I end up with negative 2 square root of 10 over 7. Am I done? No, because nobody asked me for cosine, right? They asked me for secant. But the secant is the reciprocal of cosine, right? So the secant of beta is equal to 7 over 2 square root of 10, and it's negative. And then I just have to rationalize. So I get the secant of beta is equal to negative 7 square root of 10 over 20. When you do these, your work has to be in an organized fashion, okay? It doesn't have anything to do with handwriting. It has to do with your work being all over the place. Can't happen. It has to be in an organized fashion that somebody can follow to figure out where you got it. It's kind of like doing a proof with some of these, right? I've got to be able to figure out where stuff came from. You can't just all of a sudden in the end have an answer, okay? Questions? We good? All right, so let's look on the back. Okay, so on your unit circle, if I draw a triangle, this is theta, right? So we pretend like the unit circle's on there somewhere. And I know that the x value is my cosine, right? And I know that my y value is my sine. And if it's the unit circle, the hypotenuse is 1, right? So you ever heard of the Pythagorean theorem? Yeah, a few times, right? Sounds familiar? So you know it's a squared plus b squared equals c squared. So guess what? Cosine squared plus sine squared equals 1. That's where the Pythagorean identity comes from. Okay? It literally comes from the triangle on the unit circle. Does that make sense to you? That's why cosine squared plus sine squared equals 1. You will also see it as sine squared plus cosine squared equals 1. It really doesn't matter what order it's in. But here's what I want you to understand about how this works. When I take this, I'm not going to write out the whole thing, but when I have this and I square it, okay, the way cosine theta squared is written is cosine squared theta. Those mean the same thing. You don't square cosine and square theta. It's not like you're distributing, right? Because these two things are not being multiplied together. This is how it's actually written. Which means if I know what the cosine of theta is, this just means take whatever that value is and square it. Okay, so these are the same thing. Okay, So this says use Pythagorean identities because, again, once we get halfway through one of these, there'll be another way we could do it, but it's specifically telling me to do it this way. So it says to find cosine if and tangent, I want both of these, if sine of theta is negative 1/3 and cotangent is less than 0. Your quadrant matters because think about this. When you take, what's the square root of 25? It's plus or minus 5, right? Okay, that's how we're supposed to think about it. So when you take the square root, you get plus or minus. And whether it's positive or negative depends on which quadrant you are in. Make sense? That's why you need to know what quadrant you're in, because it could be either one. So if sine is negative and tangent is negative, what quadrant are we in? Fourth. Okay, so we got to keep that in our minds when we write our final answers. Okay, so I'm looking for cosine squared theta. That'll be plus, I have sine, that's negative 1/3 squared equals 1. I just substituted it in. So that means that cosine squared theta plus, what's negative 1/3 squared? 1/9, exactly. That's equal to 1. So now I got to subtract 1/9 from both sides. So I really look at this 1 as what? 9 over 9, yeah. So when I subtract, I get cosine squared theta is equal to 8/9. Then I take the square root of both sides, which means I'm going to get cosine of theta equals, what's the square root of 8 once I've simplified it? 2 square root of 2. You ain't got no time for tree on something like that. Over 3. Now, is this going to be positive or negative? Positive because we're in the fourth quadrant, right? Because I actually get a plus or minus when I take the square root. But in the fourth quadrant, cosine is positive. That's how I know to leave it positive. Everybody with me on that? Okay, so now I need to find tangent. So I got cosine. I need to find tangent. So I have this right here that I could use. But that would require me having secant. I don't have secant, but I do have cosine. So I could find secant, right? But if I totally messed up cosine, I have like no hope on the other one, right? But sine can also get me cosecant, right? Remember, it's always safer to use what they gave you if you can. You don't have to. We could use either one of these. It doesn't matter in the end, but I don't love that number, right? And, you know, I mean, it's not that bad. But guess what? If I use cosecant, that's the reciprocal of sine. So the cosecant of theta, what's that? -3. Okay, so like you decide which one of these two you want to use, this or the reciprocal of this one. Yeah, I think I want to use the -3 also, okay? Now, in the end, that'll give me cotangent, but that's fine. I can get tangent from that. So I come over here. I'm going to do cotangent squared of theta plus 1 equals -3 squared. So that's going to give me cotangent squared theta equals, well, -3 squared is 9. I subtract 1 and I get what? 8. And so that means when I take the square root of both sides, cotangent of theta, square root of 8, when I simplify it, is 2 square root of 2. And is this going to be positive or negative? Negative, because I'm in the fourth quadrant, plus it already told me that cotangent was negative, like flat out told me. So that's not my final answer, but I need that, right? So what I really want is tangent, which means that the tangent of theta is equal to 1 over -2 square root of 2. So that's going to give me -2 square root of 2 over 4. And that is my tangent of theta. They're like little puzzles. Any questions at this point? We all good? Okay. Let's look at number 5. I want to find tangent and sine if secant is 6/5 and sine is greater than 0. So what quadrant would this have to be? First, if cosine and sine are both positive, it has to be in quadrant 1, which means everything's positive. Okay. All right, so I have secant. Let's see, I have a Pythagorean identity up here with secant in it that will give me tangent, so that's good. So we'll start with that one. So I have the tangent squared of x, because they're using x's here, plus 1 equals 6/5 squared. So that means that tangent squared x plus 1 equals 36/25. So when I subtract 1 from both sides, I'm really subtracting what? 25/25. So when I subtract that, what am I left with? 11/25, right? So then I can take the square root of both sides, and I get that the tangent of x is equal to the square root of 11/5. Any questions at this point? All right. So I also want the sine. All right. So sine I have in this right here, or I could use cosecant, but I don't think I really want to use cotangent. But guess what? They gave me secant. That means what else can I find really easily? Cosine. The cosine of x is 5/6. So now I can get sine just by using that original Pythagorean identity, right? Cosine squared theta, so this is 5/6 squared, plus sine squared theta, or x rather, I'm sorry, is equal to 1. So this gives me 25/36 plus sine squared x equals 1. So I'm subtracting 25/36, which my 1 I really want to think of as 36/36. Whether you rewrite it or not, that's what you should be thinking. And that means that sine squared x is going to equal what? 11/36. So sine of x is the square root of 11/6. And it's positive also because everything's in the first quadrant. Questions about that? Are we good? Yes. All right. So that's using the Pythagorean identities and all the other stuff that we already knew. Now we're going to look at cofunction and even and odd identities. These cofunction identities here, remember how we looked at the graphs and sine and cosine is just a horizontal shift of sine. It's just a phase shift. That's basically what this is saying. If I shift this back, I'm going to get this, it's the same as sine. Well, that works for cosine also, and for tangent and secant and all the rest of them. Okay, like it all just kind of works out that way. This right here, be very careful with this because last period people were trying to just like factor out. When I have this right here and the sine of negative theta equals negative sine of theta, I'm not factoring out that negative. That is not what is happening there. Because notice here, cosine of negative theta is equal to cosine of theta. There is no negative sign there. That's why you need this to refer to, because chances are pretty good, especially right at the beginning, you're not going to just know what they are. Eventually, you're going to know some of them because you just use them so often, but use this to refer to, especially at the beginning. Even if you think you know, double check yourself. Otherwise, that one little sign can just mess everything up, and you don't want that to happen, okay? This is all about substituting, writing it down, keeping your work organized, and substituting what makes sense, okay? And you get to make these decisions. Sometimes you can choose one thing or another, and it doesn't matter. So you and your neighbor could be working through it a little bit differently, and then end up with the same thing in the end. That doesn't always happen, and it happens when they get a little bit more complicated, but just keep that in mind as well. So what you're trying to do is figure out how you can take what you have and get what they're asking you for, okay? So I've got the sine of negative theta equals negative 0.97. Okay, so here's what I know. I know this right here. I know that the sine of negative theta is equal to negative sine of theta. So I'm going to write that down. Then I'm going to substitute because you know what? I know what the sine of negative theta is. They gave it to me. It's negative 0.97. So I'm going to substitute that in right here, negative 0.97. That's equal to negative sine of theta. Well, guess what? Now I can tell you that the sine of theta is positive 0.97. Everybody good so far? Now, that's not my final answer, but this is a piece that I need. So now I need to look at what I know about this over here. They gave me cosine, or they want me to find cosine of pi halves minus theta. Well, that is just equal to, see when you find it right there, bam, that is equal to the sine of theta. Therefore, cosine of pi halves minus theta is equal to 0.97. And you're done. Okay. Any questions at all? Let's look at the next one. I'm going to start number 7 out here because we're going to need a little bit more room. I have the tangent of negative alpha. Okay? What is the tangent of negative alpha going to equal? Negative tangent of alpha. Good. And so on your little card there, or on, on your reference sheets, or when you look at these things, they're going to always use theta because that's just the generic. But if the problem is using alpha or beta or whatever, just make sure you're doing that as well. Okay, so we have this, which means now I can substitute this in here. So I get negative 2.36 is equal to negative tangent of alpha. That means that tangent of alpha is equal to 2.36. Okay? And I'm going to hang on to that and go figure out what I can do with the other part. Okay, so I'm looking for the cotangent of alpha minus pi halves. Can I pull that off of the reference up there? No, because pi halves comes second, right? It's got to come first. Up here, you see how all of these have pi halves minus theta? That's not what this says. So we have to manipulate this. Here's what I do know. I'm not pulling any of this off of that up there. I can take this, and I have the cotangent of alpha minus pi halves. That has to be equal to the cotangent of negative pi halves minus alpha. See how I just factored out a negative 1? Everybody okay with that? All right, so now I'm going to look back up here. So basically I have cotangent of a negative angle. If I have cotangent of a negative angle, that just gives me negative cotangent of that angle, right? So now I can take this right-hand side right here. I'm going to rewrite this. Cotangent of alpha minus pi halves is equal to negative cotangent of pi halves minus alpha. Everybody with me so far? Okay, so now the negative version of this is not up there, but the positive version is, and so I could just make whatever it's equal to negative. So when I find cotangent of pi minus theta right here, that's equal to the tangent of theta. So if I have the negative of this, that means I can just substitute tangent in here and make it negative. Does that make sense to you? Just got to watch your signs there. So that means I have here that cotangent of alpha minus pi halves equals negative tangent of alpha. So, do I know what tangent of alpha is? Yes, I do. Not only that, but I didn't even have to go this far. Because in the end, of course I didn't know this when I started, but in the end I actually want negative tangent of alpha. I have that right here, and that's this. So whether I substitute that in for the whole thing or this in just for the positive part, you get the same answer either way, it doesn't matter. But in the end I get that the cotangent of alpha minus pi halves is equal to negative 2.36. And the calculator ain't going to help you with jack on this. Okay, you have got to understand how to manipulate it. Most of that is basic algebraic manipulation. You just have to substitute in different things and understand that in a situation like this, you are not just factoring out that negative. It doesn't work that way because this is not multiplication in here. Okay, questions? All right, you work on number 8 while I pass out the assignment, and I'll let you kind of get started on that, and then I will help you work through it. But try and think through it on your own. You can't just go, okay, I'm going to start it just like this other one. You have to decide how it's going to start and what you're going to use. Like all of this is just about you figuring it out and understanding the concepts. All righty. If you did not work it as I start to work through this one, if you didn't work it exactly like I did, that does not mean that you need to start erasing. Hang on, I don't know why it keeps jumping. Okay, so once again, I have to manipulate this here. So this is going to become secant of beta minus pi halves is equal to secant of negative pi halves minus beta, right? Okay, so when I look up here, the secant of a negative angle is not equal to negative secant of the angle. Secant of a negative angle is equal to just secant, right? So that means that secant of beta minus pi halves is equal to secant of pi halves minus beta. Which means then I can substitute this in for this right here, and so I get negative 3.62 is equal to the secant of pi halves minus beta. Everybody with me so far? Okay, so secant of pi halves minus beta is equal to cosecant of beta. So I can substitute this right here in for cosecant. So negative 3.62 is equal to cosecant of beta. I don't want cosecant of beta. I want cosecant of negative beta, right? So once I look back up here, cosecant of negative beta is negative cosecant. So if I multiply this through by a negative 1, I can get 3.62 equals the negative cosecant of beta. Now I have this part that I needed, which means that cosecant of negative beta is equal to 3.62. There is my answer. Okay. Questions? Okay. So did you make this negative here? This one? Okay, so remember, it does not factor out. Remember I said that at the beginning. It absolutely does not factor out. This basically means, like if I substituted, I'm looking at secant of negative theta, right? Okay? And if you look up here, secant of negative theta equals secant of theta, not negative secant of theta, because it's not a factoring out. That's why we have to have different rules. If we just factored it out, we could just not even have this written down. We could just factor because we know how to factor. Does that make sense?
Okay, so for the cotangent one on number 7, that one because the rule actually
Yes, because on number 7, this is what it equals. That's why you have to refer to this, because things change. Does that make sense? And one little sign can throw you off completely. And right now, it's just changing the sign on the final answer. But once these get into equations and other things, it's going to mess up a whole lot. So you have to be very, very diligent in all of that. Any questions? They're like little puzzles. Have fun with them. They're going to train your brain. Okay? If you want that little half sheet, if you want one for your ISN and you want another one just to like keep in your binder, you can take another one and I can print more off. Some people might just want it in their ISN or whatever, but you can grab another one and that's fine. Any questions at all? All right. So go ahead and get started.